Hey guys, this is Mr. Fourth Dimension, and we're here for another episode of the Geo Project. Let me get this set up. Last time we got angles started, and I want to take another 15 minutes to revisit that angle stuff because I did some thinking about it over the weekend because this is a Monday, and I think that I want to do the angles a little differently. We might be able to speed it up a little bit if we do them differently. Plus, I think having the negative angles isn't going to be such a good idea for some of the things we want to do with it down the road, possibly. Some thoughts I had just suggest that we might want to have, basically, instead of having 0 to pi and then 0 to negative pi, it'll just go from 0 all the way around to 2 pi. So, let's see if we can get that change done. Geodirection. So we're taking and saying if x is 0, right? So this will be different. This will be times 3 times pi over 2. This is saying if x is greater than 0, right? So if x is greater than 0, that gives us the reassurance that this, right? Well, that this is going to decide the sign of it. So we're basically, if you imagine that this is a y-axis here, we're basically on this side of the y-axis, right? So if y is positive, then this is fine. If y is negative, it's not going to work so much. So it looks like we might need to do another one of these for now. And like I said, I don't necessarily love the fact that we have all these ifs in this, but we're going to try to fix that too. So if that is the case, then we want to do 2 times pi minus, or plus this amount. So if y is negative, then this is going to be a negative angle this direction. And we want to turn that into a positive angle by taking 2 pi, by basically adding 2 pi to it, basically, so that it wraps around and is somewhere less than 2 pi, but greater than pi, because this will be, well, this will actually be between 0 and pi over 2, right, because it's here 0, pi over 2, it'll be in that range. Now if x is negative, then if y is positive, this turns out as a negative, right? So that's where we're down here, and then that adds around to here, so that's correct. Now if we're in this case, x is negative and y is negative, right? Because y is less than 0, 2, and we want it to come down here and be more than pi at that point, but less than 3 pi over 2. So right now what it's doing is it's actually giving us a positive in this direction. So if we add pi, we should get what we want there as well. So that's good. That means we can reduce this case down to just this. Alright. Yeah, okay. If y is greater than 0, yeah. So I'm looking to see if there are other ways we can combine these things. Like if x is 0, say that it's pi over 2, and then add pi here is kind of like the fact that we add pi here, but it's not really the same. Let's just make sure that everything works here. So we're going to do the loop with x going from negative 5 to 5 and y being positive 2 to start. Alright, where is my, there it is, run. So what do we got here? It's starting not quite at pi, and then dropping to not quite to 0. Everything looks about right. Let's add those up to see if they would make sense. In other words, the distance from here to 0, from the 0.38 to 0, should be the same as the distance from here to pi. So I'm suspecting that if I do something like 2.761, and if I haven't made some gross mistake, that should be pretty close to pi, and it is. Cool. Okay, let's also test the negative realm. Whoops, numlock is still on. Okay. Now this one, again, it should be increasing all the way through. whereas this one was decreasing to not again, but I'm thinking again because like last time that's what we looked for a lot. And it's starting a little bit after pi and getting a little bit up to 2 pi, and again the distance from there to there should be enough that well, the distance from pi to here should be equal to the distance from 2 pi to here, if everything is working out. And then the distance to this, and this in particular should be this 4.7 here, that should be 3 pi over 2. So we're going to check both of those. First of all, let's do 3.522. Oops, now I need an unlock. 3.522 minus 3.141. So 0.381 again. And then do that plus 5.903-ish. 6.284. Right, that's about 2 pi. If I divide by 2, yeah, round it up. And then if I take 3.14159, like something like that, and I do times 3, and then I divide that by 2, I get to 4 points. Yeah, so that's coming out correctly. This is a continuous spectrum from large to small to large, so that's good. Let's test the 0 here. Oh, gotta build. So now it's starting at pi, and it's going until 2 pi. That's not right. I don't want this to be 2 pi. Where is it 2 pi? Here. If x is greater than or equal to 0 now is correct. The reason for that is if I don't do equal to 0, then it comes down here and it does 2 pi where I want it to do 0. Because it's basically taking 0 and adding 2 pi to it. There we go. So it's going from pi... this shouldn't actually be... This shouldn't be the way it is either, because look, we want this case to be a continuous line too, so that should point up instead of down now. So that is in this case, if y is greater than or equal to 0 is what we want. Okay, cool. Let's take a quick look and see if we can think of a way to combine any of this now. Y is greater than or equal to 0. So positive y's, right, are we might need a cleverer way to do this whole computation. So maybe this is something to return to with when we start looking at it with a diagram or something. But what I'm seeing here is that you've got this repeated if here, and basically, what's the difference between these? Well, this is plussing a pi when y is less than 0. This is plussing 2 pi, and the reason it's different is because this right here is negative, so we're adding 2 pi to make it all the way around to positive. It's not a problem with this case, because when it's negative, it adds pi and it comes up here to positive, and if it's here, it adds pi and it's positive over here where we want it. So this is for that case where it's in the negative quarter, and this is for that case where it happens to be in the positive quarter, and that's where we want it to be directly. Right, so it looks like basically, besides this, the basic cases are we want to add pi or 2 pi. And the deciders on this are positives and negative qualities of x and y. So negative x always adds a pi. Positive x, negative y always adds 2 pi. Yeah, it's hard to say. I think that for now I'm going to leave it like this, just because I don't want to spend an entire video going over possibilities in my head that don't ever work out in the end. But I definitely don't like the fact that there's there's 2 ifs or 3 ifs in this chain, right? So you could take at least 3 ifs to figure out what computation to even do. Another thing I want to do today is I want to pull out, now that we have arctangent in a few places here, and that's one math function, and then where we have square root up here somewhere, I want to pull out the math stuff, and I'll explain why as I do it. Basically what's going on is we have these functions that we're using directly from the standard library right now. So like we're using the standard libraries atan and the standard library square root, right? Well, those aren't necessarily the fastest ways to do those operations, and I want to make it fairly simple to optimize those functions. So if this becomes something I want to reuse, one thing I can do to make it more reusable is separate all that math code out into one file, and then when I want to optimize the math for a particular platform or with a new idea or someone else wants to do their more clever way of optimizing than what I know how to do, they can go in there and change that file to optimize better. So that's going to look like this. It's going to include the math for now, right? And this is where include geomath.h, and then let's see, we're going to have an inline square root for now. This is the first one we need, and that'll return a real 32. This will be math square root inline. I'm not sure if we need inline and internal at the same time. Maybe we don't, but I'm going to keep it because I'm not sure. Math square root real 32 x, and then it's just going to be the square root of x for now. So it's not going to do anything different than what we're doing. It's just going to add that extra layer of separation, so we're not using the math directly in the big messy code. So that way there's only ever one place where I ever call square root from the math header, and there will only be one place where I call atan. And anytime we use a new math function, we'll have to add it here. Math atan. And then, let's see, that's just going to return atan x. And down here where I call atan in a few places, I turn those into these. Alright, so we got that out of the way. That's cool. How much time are we looking at? 2.5 minutes left. What to do? I guess I'll do some more thinking about this. So, the main problem to deal with is that this function here is giving us our answer in terms of one thing we could do is take whatever we get and always add 2 pi. So we would get stuff in this range would be correct and stuff in this range would be too high. And then if we notice that x is negative, right, this case, we add another pi, so it'll rotate around again, and then finally if it's larger than 2 pi we subtract 1. Right, so that would look like this. If we're not in that case, we take 2 pi here, and we'll store this temporarily. We'll call this like the result equals, and then we add 2 pi, and then we say do a second if p.x is less than 0 strictly, so that is we're in this half of the circle, then take what we have and add another pi. This is still going to have to do 3 ifs, isn't it? This is going to do 1 if there, 1 there, because then the last thing we have to do is if result is greater than 2 times pi, then we do result minus equals 2 times pi. I'm not convinced that this is any better now that I look at it, because we still have to do 2 ifs in here to get to the answer. In fact, we always have to do 2 ifs now. But maybe we're on the right track. Because the idea is if you have that there, then you're just going overboard by a bit. And then you still have to check and see if you're on the right-hand side when you should be on the left-hand side. So there's always going to be a check to say, hey, should I be on the left-hand side instead of the right-hand side where I am? Right, that's always going to be there. unless we can figure out a way to do this as like round all negatives to a positive 1 kind of situation. I don't think you can do that. Alright, we're going to leave it the way it was, but we might be getting close to an idea there. Alright, so we made a little progress. Hope it's been interesting, and see you guys next time.